In the blink of an eye, humanity has transformed the planet. Cities tower above the clouds, technology evolves at lightning speed, and energy powers a world once thought of as unimaginable. Our ambition has reshaped landscapes, fueled economies, and connected billions. Innovation has become the cornerstone of our progress. But with progress comes a shadow, a growing imbalance in the natural world. As we burn fossil fuels to power our lives, the air fills with greenhouse gases, trapping heat and disrupting the planet's delicate climate systems. The consequences are stark. Rising global temperatures fuel deadly storms. Once predictable seasons turn chaotic, and droughts threaten livelihoods and food security across the globe. From the melting Arctic to the burning Amazon, the evidence is undeniable. Our planet is changing, and with it, the lives of millions are being upended.
Wake up, planet Earth. Scientists know that the Earth's temperature has been stable since the end of the last major ice age, some 10,000 years ago. At least it was stable up until the middle of the 19th century. Then something strange started happening. The Earth started warming up at an alarming rate. This coincided with the start of the Industrial Revolution. Since around this time, humans have been in a total struggle for competition, for global domination, improvement to hygiene, mechanization, science, living standards. This has resulted in an explosion in human population. Many senior citizens have seen the world's population mushroom in their own lifetime from 2 billion to nearly 9 billion today. Human successes and failures have come at the cost to our environment. Today, we are living on borrowed time. The Earth is now at least 1.2 to 1.5 degrees centigrade above its pre-industrial level. The climate is changing at such a rapid rate that we're all beginning to take note. Many scientists now believe that if we don't cut emissions to zero, the Earth is going to become an inferno with apocalyptic repercussions for mankind. This could be the death knell to mankind as we know it today. This year was the hottest year on record yet. 2023 is a premonition of what is to come. In 1995, an IPCC report stated that was expected to be little change in the levels of locked-up ice in the Antarctica frozen ice cap over the next 100 years. How wrong they were. In March 2022, large swathes of East Antarctica experienced a heat surge of up to a staggering 40 degrees centigrade above normal. This was the highest temperature anomaly ever recorded on Earth. Antarctica is succumbing to climate change. The Earth's greatest refrigerator is starting to defrost. Huge areas of sea ice are disappearing at an alarming rate. After the summer of 2023, the area of ice missing from the Antarctic oceans reached an all-time high. By the time winter came around, the ice that returned was missing an area the size of Greenland compared to the year before. The melting of the Antarctic ice cap is especially important as there is enough ice locked up in the Antarctic ice sheet to raise the sea level by 60 meters. The fact that both the Antarctic and Arctic ice caps are melting will have a vast impact on global climate change for all of us. It will also have a devastating effect on the ocean temperature, currents, and sea nutrients that feed the food chains in the ocean upwellings around the globe. What is most worrying is that the rate of melt of the polar ice caps and the sea ice is expected to rise exponentially over the next few years. 2023 and now 2024 is marked by record heat waves. A weather station in Samboa, China, registered a record of 52.2 degrees centigrade on the 16th of July 2023. A few days later, Beijing also recorded its highest ever temperature of 41.1 degrees centigrade. At the same time, inside Siberia, Russia, where one wouldn't expect heat waves, Yekaterinburg recorded its highest temperature of 40 degrees centigrade. In Europe, the same pattern of heat waves emerged. In Athens, the ambient temperature reached 43.4 degrees centigrade, and records were broken in Sardinia, Italy, where the temperature reached 43 degrees in July 2023. Also, the Americas were not to escape these record 2023 heat waves. On the 16th of July 2023 in Death Valley, California, the allegedly highest ever temperature of 55 degrees centigrade was recorded. Phoenix, Arizona had 31 consecutive days where the temperature exceeded 43 degrees centigrade. And in Mexico, the temperature was so high that it affected the local wildlife. Native howler monkeys were falling out of the trees and dying in high numbers. Closely associated with heat waves are droughts. The severe record droughts of 2023 severely affected commerce on the Mississippi River Basin and on the Panama Canal, where water levels went down to levels which impeded movements of commercial shipping. The Amazon River Basin experienced its worst drought ever. In Manaus, the Amazon River shrank by 12.7 meters. Some of the river water reached 40 degrees centigrade. This resulted in anoxic water conditions, massive fish deaths, and poisoning of the river water. This climatic change has been aggravated by the loss of the Amazonian rainforest over the years. About 20% of the Amazon has already been deforested and a further 40% degraded over time. Water stress has been the cause of placing a further 37% of the remaining Amazon rainforest at risk of dying. This is also making the Amazonian rainforest prone to fire. Furthermore, during 2023 and 2024, the world experienced record numbers of wildfires. Wildfires were witnessed in Algeria, Tunisia, Sicily, Dubrovnik, Rhodes, Portugal, Turkey, Bulgaria, Croatia, Albania, southern Italy, and most memorably, the ferocious wildfires in Greece. Wildfires are also nothing new to North America, but the scale witnessed in Canada during July to November 2023 was completely unprecedented. 900 wildfires were recorded, with 500 still out of control in November. This consumed at least 18 million hectares of forest, and smoke sped south and blanketed the USA with a layer of foul smog, causing a lot of health problems as far south as New York. Climate change has also led to record high sea temperatures. The ocean is the largest solar energy collector on Earth. Not only does water cover more than 70% of our planet's surface, it can also absorb large amounts of heat energy without significantly increasing the sea surface temperature. 91% of the heat energy which gets trapped in the atmosphere as a result of the greenhouse effect, caused by the buildup of greenhouse gases, has been absorbed into the ocean. The amount of energy absorbed in the sea is equivalent to the heat energy of detonating 5 Hiroshima atomic bombs per second for the last 25 years, a near unimaginable amount of energy. The heat energy that is locked up in the oceans is leading to steadily higher and higher sea surface temperatures. Record high sea temperatures were registered in our oceans for 9 consecutive months in 2023. With the average global sea surface temperature reaching a record of 21.1 degrees centigrade on January the 20th, 2024. This is probably the warmest that the oceans have been for 100,000 years. The effect of rising sea surface temperatures is to increase the moisture uptake into the atmosphere and affect the weather. Because climate change has brought about the increase in sea and atmospheric temperatures, this has resulted in a global increase in frequency, number, power, and severity of cyclones, storms, and floods that are occurring globally. However, there are periodic anomalies. These hotter than normal 2023 recorded temperatures would have been boosted through the release of vast amounts of heat energy into the atmosphere by the strong El Niño effect in the Pacific. These higher than normal temperatures will continue into 2024, despite the Pacific returning to a La Niña state late in 2024. The El Niño and La Niña are the 3 to 7 yearly cyclical opposing weather patterns that break the normal climate trends. Scientists call these phenomena the El Niño Southern Oscillation, ENSO cycle. The El Niño and La Niña can both have global impacts on weather, wildfires, ecosystems, and economies. Episodes of El Niño and La Niña typically last 9 to 12 months, but can sometimes last for years. This has led to record flooding in many parts of the world. Here again, China was one country that was greatly hit by flooding. In July 2023, 16 cities and provinces in the northeast experienced record flooding due to Typhoon Doksuri, and Beijing experienced its heaviest rainfall in 140 years. In May 2024, at the same time that Delhi was suffering from heatwave temperatures of up to 49.6 degrees centigrade, West Bengal and the northeastern state of Mizoram were struck by gales and lashing rains from Cyclone Rimal, which hit India and Bangladesh, killing more than 38 people. The Bangladesh Meteorological Department said that the cyclone was one of the longest in the country's history and blamed climate breakdown for the shift. Climate change was also said to be affecting India. In 2023, Shimla received exceptional rainfall which resulted in severe flooding, caused landslides and loss of life. Europe and North Africa did not escape the floods, and we are reminded of the dangers of flash floods when 11,000 people lost their lives in Derna, Libya, on the 10th of September 2023. Record flooding was also witnessed in Greece, Spain, Italy, Turkey, Bulgaria, and France. Southern Brazil's location at the confluence of the tropical and polar currents has fed periods of increasingly intense drought and rains due to climate change. Record rain in parts of the Rio Grande do Sul state, Brazil, in May 2024 led to flooding, the displacement of 250,000 people, and a severe loss of life. The exceptionally warm conditions experienced globally as a result of the El Niño in 2023 brought on two of the most devastating and powerful cyclones which occurred in the Pacific and Indian Oceans. Cyclone Freddy and Cyclone Otis wreaked havoc on reaching land. Cyclone Freddy became the longest-lived cyclone ever recorded and was, at that time, officially the Earth's most energetic storm ever observed. The deadly tropical cyclone built up energy as it traversed the warm southern Indian Ocean for more than 5 weeks in February and March 2023. When it eventually reached landfall, it caused significant damage to Malawi and the coastal communities of Mozambique and Madagascar. Also, the heating up of the oceans has had a massive effect on organisms living in the oceans, and most notably the coral reefs. Just a 1 degree centigrade rise in temperature over a period of 48 days is enough to kill the symbiotic algae living in the coral and hence deprive the coral polyp of its food source, which will lead to its death, a process known as coral bleaching. 98% of the Great Barrier Reef has already been bleached. This is also especially damaging because 1 in 4 marine species in our oceans is dependent on coral for their habitat survival. Furthermore, approximately 30% of the carbon dioxide that is emitted into the atmosphere gets absorbed into the seas. This combines with water, producing carbonic acid, a process known as ocean acidification. The pH has dropped by 40% in some parts of the oceans and is projected to drop further to 7.8 by the year 2100. This may not sound a lot, but it represents a pH drop of 150% from pre-industrial times. The change in pH will have an effect on all the marine life that relies upon calcium for some of their structural biochemistry, as it makes it more difficult for these marine organisms to keep their outer shells. Ocean acidification has already had a detrimental effect on the population numbers and growth of mollusks, crustaceans, and coral reefs in some ocean coastal areas, and will increasingly have an impact on the phytoplankton and zooplankton in the lower parts of the food web that are acutely sensitive to changes in pH. Besides this, around 40% of the global human population relies on seafood as a significant source of protein. A change in pH could undoubtedly have a detrimental effect on the catches of fish and hence the economies and people reliant upon fishing for their livelihood. The main driver of climate change is carbon dioxide. Although there are other greenhouse gases, carbon dioxide is a very good indicator of climate change, as its increase in concentration since the Industrial Revolution is very closely correlated with the increase in atmospheric temperature. Since 1800, the upward slope in carbon dioxide in gigatons indicates that there is little slowing down yet in the burning of fossil fuels. World governments will need to take drastic steps in order to stop emissions and apply the principles of the Paris Climate Change of 2015, which set out to try and keep the world within 1.5 degrees centigrade of the pre-industrial level. The world has already breached this level of 1.5 degrees centigrade in August 2023 and could reach as high as 1.8 degrees centigrade sometime in 2024. The addiction of world business to easy financial profits from the oil industry has proved too alluring. All governments are currently reneging on their agreement to honor the 2015 Climate Change Agreement. Oil companies are still planning further oil exploration searches for new oil reserves. World governments have still not paid heed to the warnings of climate scientists. This is highlighted by the fact that the global fossil fuel subsidies have increased to $7 trillion in 2022. This is equivalent to a staggering 7% of the world's gross national product. There have been few or little attempt by governments to dampen this increasing demand. Many climate scientists now predict that if we don't cut emissions of carbon dioxide from 35 gigatons per year to zero by the year 2050, the Earth's atmospheric temperature will, under current projections, increase to more than 3 or even 4 degrees above its pre-industrial level by the year 2100. One must be aware that even an 0.1 degrees change in atmospheric temperature has a tremendous effect on the climate. The weather extremes will only worsen as we continue to pump more and more greenhouse gases into the atmosphere.
We are on a highway to climate hell with our foot still on the accelerator. We are getting dangerously close to the point of no return.
Indeed, the increase in heat wave extremes will make parts of the globe uninhabitable. If the world atmospheric temperature rises by 3 degrees centigrade above its pre-industrial level, then it is estimated that areas of the Earth that will be too hot for human existence will rise from its current 1% of the global land surface area today to cover at least 19 to 20% of the Earth's surface. The projected sea level rise could be 1 meter or even more this century. This will displace hundreds of millions of people. Furthermore, the immeasurable damage due to flooding and drought will bring about mass migration to safer areas. The root of climate change is a function of both the numbers of people living on this planet and their per capita emissions of greenhouse gases. There are just too many of us living unsustainably in this world today in order for the Earth to be in a sustainable state. The idea that we humans can calculate our population in such a way that is sustainable is nothing new. Many people have speculated about trying to develop sustainable population models that could help us understand if a particular country was living sustainably or beyond its means. Probably one of the most celebrated and controversial individuals to attack this problem was Thomas Malthus, who in 1798 published his theory on population. He stated that populations will inevitably expand until they outgrow their available food supply or the growth of those populations are reversed by disease, war, or calamity. If a model that connects population numbers and human consumption patterns to environmental sustainability could be developed, then this would prove to be a very useful tool for both governments and scientists alike. Such a model to be useful would need to be scientifically based, robust, accurate, transparent, stand up to scrutiny, and easy to understand. In the early 1990s, a couple of pretty bright individuals, Dr. William Rees and Dr. Mathis Weckenagel, developed the idea of an ecological footprint model. This model is now promoted by an organization called the Global Footprint Network. The ecological footprint is now a household name. Every year, scientists from the Global Footprint Network calculate two very important fundamentals. Firstly, the biocapacity, and secondly, the ecological footprint for every country in the globe. Both biocapacity and ecological footprint are expressed in units of global hectares. This makes it possible to compare countries and individuals. The sun's energy, through photosynthesis, produces all the products that we require on Earth, i.e. the Earth's total biocapacity. Biocapacity is also known as all the ecological assets produced in a year, i.e. the productive area available to produce all the resources we use, and also the area required for our waste. The ecological footprint, on the other hand, are all the things that we need to consume, i.e. the Earth's outputs, and put simply, measures how much land and water area that we need in order to produce the resources we use, i.e. things like energy, timber, food, land for settlement, seafood, and absorb the waste that we generate. It's like a simple equation. Inputs must be equal or more than the outputs for the Earth to be in a sustainable state, i.e. the Earth's total biocapacity must be equal or more than the Earth's total ecological footprint. The results can be schematically color represented on a world map. Where the ecological footprint of a country is in excess of its biocapacity, a term known as an ecological deficit, it is said to be living unsustainably. Where a country's biocapacity is in excess of its ecological footprint, that country is said to be an ecological creditor, i.e. that country is said to be living sustainably. The Global Footprint Network, in its annual calculations of ecological footprint and biocapacity, uses 15,000 data points per country per year. Where there are records, the calculations of ecological footprint and biocapacity go back as far as 1962. Note how many countries that are ecological creditors in 1962 go into ecological deficit by 2015. Here is a graph that plots over time, since 1962, side by side, the Earth's total biocapacity and the Earth's total ecological footprint. Note how the Earth passes from an ecological reserve to an ecological deficit in the early 1970s, when the world had a population of 3.5 billion. Today, 85% of the world's population live in countries which are in ecological deficit. Simple logic tells us then that the world, under its current consumption habits, would need to reduce its population by at least 2/3, i.e. reduce its global population to about 3.2 billion, if this planet is to move back into a sustainable state. The world is changing fast. We need a way of easily quantifying, understanding, measuring, and hence comparing the sustainability of different countries. One of the best ways we're going to be able to achieve this is through a concept known as the Sustainable Development Index. We start with a fundamental utopian idea. We want every human being on this planet to live full and sustainable lives. For this to happen, we will need to receive a good education, earn enough money so we have sufficient material wealth to be happy, live long and healthy lives, good longevity, but at the same time, not damage the environment or harm this planet. The United Nations has developed a concept known as the Human Development Index, or HDI for short, which measures the first part of this utopian ideal above. The Human Development Index is made up of 3 component parts: longevity and health, education, and income. The United Nations then produces annual statistics for the HDI for every country in the globe. In this diagram, you can see the changes in Human Development Index plotted for every country on Earth from 1990 to 2021. One of the lowest HDIs is Sudan, with a Human Development Index of 0.381 in 2022. At the other end of the scale, we have the superbly rich, well-educated, and extremely healthy persons from Switzerland, who has an HDI of 0.91. Note how the HDI for every country has improved since 1990. So, the Sustainable Development Index is simply a plot of the ecological footprint against the Human Development Index. Firstly, we need to define what we mean by a high Human Development Index. The figure of 0.7 has been denoted by the United Nations as a high threshold of Human Development Index. Note how we plot the threshold number of 0.7 HDI on the x-axis. On the vertical axis, we will measure the impact that each country is having on this planet by its ecological footprint in terms of equivalent numbers of Earths. We know that on this Earth, there are 12 billion global hectares of usable productive land for 8 billion humans living on this planet. In order for this planet to be in a sustainable state, the ecological footprint of this Earth must not exceed 12 billion global hectares. Currently, the Earth's ecological footprint is much greater than its biocapacity, i.e. humans are consuming and polluting more than the Earth's capability to regenerate what we are consuming. This is so much the case that it would currently take annually 1.75 Earth's biocapacity to sustain the Earth's ecological footprint. Or, put another way, it would take 20 months for the Earth to regenerate what it takes or consumes in 1 year. We know that the planet's climate is changing in such a way that our lives will be increasingly more precarious in the future. This is the distribution of all countries on the planet. plotted on the Sustainable Development Index graph for the year 1990. Very few countries had the same ecological footprint. If we were all to have had the consumption habits, i.e. ecological footprint, as people from Niger, Uganda, India, China, Indonesia or Sri Lanka, then the ecological footprint of this planet would have been equivalent to less than 2/3 of the Earth's biocapacity per year. The Earth today would have still been in a sustainable state. However, these countries that have a Human Development Index of less than 0.7, i.e. an unacceptably low Human Development Index. If, on the other hand, we were to have had the trappings of a modern society, and we were all to have lived like an American or a person from the UAE, this would have been an environmental catastrophe for this planet. This Earth would have needed to have regenerated 5 times more biocapacity per year than it currently does in order for it to remain in a sustainable state. There would have been nothing left of the planet. For this Earth to be in a sustainable state, we would not wish to consume or emit more gases than the Earth can regenerate in 1 year, i.e. below that line which is the ecological footprint equivalent of 1 Earth, but at the same time have a Human Development Index above 0.7. Ideally, we would want every country to fall within this box if the Earth is to be living sustainably. Look again at the distribution of countries on the Sustainable Development Index graph in 1990. Note now the change in the pattern of the spread of countries on the graph as the time progresses from the year 1990 through to 2021. You will see, as the poorer countries develop and become more affluent, their consumption habits change in such a way that their ecological footprint is more than 1 year's worth equivalent of biocapacity as they improve their lifestyles and raise their Human Development Index. Note also that only a few countries fall within that sustainability box as countries pass the Human Development Index threshold of 0.7. The reason for this is quite straightforward. Societies in all countries have been unable to develop and adopt the carbon-emitting technologies that allow us to enjoy the trappings of a modern society without significantly increasing our ecological footprint. Fortunately, over 50% of the Earth's global footprint is due to the burning of fossil fuels. Hence, it is blatantly obvious from the Sustainability Development Index diagram that if countries that are currently living unsustainably could substantially reduce both their populations and also reduce their carbon emissions, this would push them into the sustainable box. This may be technically feasible over the long term, but in the short term, such a situation is unlikely to happen, as most of these countries living unsustainably are either unwilling or unable to invest in technologies which can reduce their carbon emissions sufficiently to become sustainable. There is good news, however. Although global population is increasing, today people are choosing to have much smaller families. As the world modernizes, so the Earth's fertility rates are falling. Malthus couldn't have predicted this. The population of this Earth is not following the Malthusian path and simply expanding until it runs out of natural resources to keep itself going. In the 1950s, about 60% of the world's population of women have fertility rates above 6 children per woman. By the period 2005 to 2010, the number of world women having 6 children or more had dropped to 8%, and 52% of the world's women had reached that magical replacement number fertility rate of 2.1. This figure of 2.1 is particularly relevant because when a population fertility rate falls below the replacement level of 2.1, that population will eventually stabilize. And when the fertility rate dips below 2.1, that population will fall. Japan, South Korea, China, and many countries in Europe today have declining populations. And for the first time in human history, with the exception of Ukraine, this is without war, famine, or disease. Although the Earth's population has increased from 2 billion in 1950 to 8 billion today, the rate of population growth has been decreasing ever since the early 1950s. This near miraculous decline in fertility rate is known as a demographic transition. This phenomenon marks a tectonic change in modern history. It represents a fundamental shift to a permanent low global fertility rate. This will transform societies in ways that we cannot yet imagine. This demographic transition is reflected in the United Nations medium-term global population projections. The global population is expected to reach its maximum at around 2075, with a global population of 10.5 billion, staying at that level for a couple of decades before steadily declining. The future projected demographic trends are mind-boggling. If current trends in low fertility rates continue, by the end of the century, the population of countries like Japan, China, South Korea, Thailand, and other countries in Europe would have shrunk by between 40 to 60%. Although many countries could, in theory, lower their carbon footprint through pursuing renewable energy policies in order to become sustainable, in reality, this is unlikely to happen anytime soon, especially for those countries trying to move their societies out of poverty. Trying to raise living standards without using fossil fuels is still proving to be economically too expensive. If this Earth is to be more realistic and practical, many countries could take advantage of their declining populations in order to lower their carbon footprint and hence eventually reach a sustainable population state faster. For instance, India is one of many countries where the ecological footprint model would describe it as overpopulated and also living unsustainably. India is a very interesting country because in 1952, it was the first country to adopt a family planning program.
Let us give serious thought to the urgent need for planned parenthood, which alone will ensure the happiness and prosperity of our children.
It has been battling to lower its birth rates ever since. Nevertheless, India has now successfully achieved that magical fertility rate of 2.1. This is reflected in the United Nations projections, which forecast that the Indian population will level off by 2065 at about 1.7 billion and then gradually decline. If India was ever to attain a sustainable population size, i.e. where its ecological footprint would be equal to its biocapacity, under the current consumption patterns, the country would need to reduce its population by at least 2/3 to 470 million people. India is only one of many countries needing to decrease its population size in order to reach a sustainable state. For instance, the USA, which has a current population of 338 million, would need to reduce its population to 169 million. And China, that has a population of 1.45 billion, would need to reduce its population to 323 million. And for Japan, with a current population of 124 million, if it was to reach a sustainable state, would need to have a population of between 20 to 40 million. The United Kingdom, with a current population of 68 million, needs a population size of between 90 and 30 million. Nigeria, with a current population of 218 million, would need to reduce its population to 118 million. Egypt, with a current population of 103 million, would need to reduce its population to 22 million. And the UAE, with a current population of 9 million, would need to reduce its population to 600,000. Obviously, the global footprint network model might appear to be off the mark, as many other considerations need to be taken into account when evaluating a sustainable population size. All nations have their own behavioral characteristics and resource-driven advantages, which should be taken into account when considering a sustainable population size. For example, the UAE could significantly boost its biocapacity and hence its sustainable population size through the manufacture of fresh water for irrigation through desalination. Obviously, trade is another way of overcoming the deficit in biocapacity. However, the global footprint ecological model should not be dismissed as too simplistic, for its methodology is based on large amounts of proven scientific data. It would not be correct to finish this documentary without describing the devastating impact that human overpopulation has had on wildlife ecosystems and biodiversity. The space required for a healthy, vigorous biodiversity is not taken into account in the ecological global footprint model when determining a sustainable human population size. The impact that human overpopulation has had on biodiversity has been the greatest loss to nature's rich tapestry on this earth. 56% of the world's population live in cities. This trend is expected to continue, with urban populations more than doubling its current size by 2050. Many of us no longer, sadly, come in contact with nature on a daily basis. This loss might be considered nearly irrelevant to most of us as we live out our everyday lives. As a result, we have changed the Earth in many unintended ways. Humans have driven 680 species of vertebrate to extinction since 1500. Globally, there has been a staggering average 68% fall in population of mammals, birds, amphibians, reptiles, and fish in the short 50-year period to 2016.
And in the Caribbean and Amazon, the loss in population wildlife numbers has been as high as 94%.
Over the ages, the loss of global wildlife habitat and biodiversity has arisen as a result of humans clearing land for farming. At least 40% of the world's forests have been lost to agriculture since the last ice age. The scale of loss has become mesmerizing. In the last 50 years alone, it is estimated that 340 million hectares of new cropland has been created globally, and 470 million hectares, around half the area of China, of natural ecosystems was converted to pasture, so that today livestock makes up 62% of the total mammal biomass, humans make up 34%, and wildlife only make up 4%, and wild birds now only make up 29% of the total bird biomass, while the other 70% of the bird biomass is made up of poultry for human consumption. Piled on top of the impact that man has had on wildlife and biodiversity in order to meet his needs for space and grow food, there is now the additional stress from climate change. Lest we forget, let's revisit two of the many, many examples of loss to nature over the last 12 months due to overpopulation and climate change. When a record-breaking heat wave in Australia exceeded 42 degrees centigrade, this wiped out 1/3 of the nation's spectacled flying foxes. At the other end of the earth, in the Brazilian Amazonian River, 150 river dolphins died as a result of heat wave and droughts. This brings the river population of dolphins that one step nearer to extinction, as this number represents 10% of the local population of dolphins. Hence, it is without a doubt that any decrease in human population in many countries will take the pressure of deforestation and loss of biodiversity. In future, we must surely take into account the requirement for space for wildlife when considering if a population is sustainable. Many people in many countries might agree that they feel the adverse effects of population stress, and India is one such example.
Make a list of all the other environmental problems that now afflict us and our poor, battered planet. The increase of greenhouse gases and consequential global warming, the acidification of the oceans and the collapse of fish stocks, the loss of the rainforests, the spread of deserts, the shortage of arable land, the increase in violent weather, the growth of megacities, famine, migration patterns, the list goes on and on. But they all share one underlying cause. Every one of these global problems, social as well as environmental, becomes more difficult and ultimately impossible to solve with ever more people.
Many governments appear to think differently. This is where theory comes up against a wall of reality. Politicians do not favor population reduction as it leads to an aging society, and they believe economic stagnation and recession. Diminishing number of working young, supporting an increasing number of people of retirement age is considered bad for the economy. So how nations and societies react to reducing fertility rates and population reduction in future is very important. How we deal with this situation is not preordained. We know that the use of government coercion in order to increase fertility rates does not work in democratic countries. Most societies have chosen, therefore, to try and fight declining population by throwing money at various policies which have the primary goal of increasing their fertility rates. France recently came under spotlight because of its policies which are attempting to stop declining birth rates through financial inducements. They have lower taxes for multiple-sized families until the youngest child reaches 18 years, have generously funded creches, give financial aid to help parents with childminders, and have even lowered the school age from 6 to 3. Financial incentives for parents to go into part-time work, generous maternity leave, 3 years paid paternal leave, travel allowances for families and children. However, even in France, the fertility rate is still falling. South Korea spent up to $200 billion over 16 years in order to try and increase their fertility rates. And this didn't work either. Blindly pursuing higher birth rates to fix economic woes may backfire. Many young will only help the economy if they are economically active. Also, nations have been developing into aging societies more rapidly in recent years. For instance, for the United Kingdom and Ireland, it took 90 years for the percentage fraction of over 60-year-olds in society to increase from 15% to 30%. But today, it took Thailand and Iran only 20 years to achieve the same change. So the message is that many countries will need to act fast if they are to escape the poverty trap before they become an aging society. Not planning for an aging society is no answer. This leads to bankrupting pension funds and messy public finances. Developing countries will need to move away from informal economies that risk poverty for the older generations when they reach their retirement age. Let's take a closer look at Japan. This is the best example of a country confronting the problems of an aging society. The rest of the world will be ultimately facing the same daunting demographic shift and will be watching Japan closely for its policy adjustments, innovations, and experiments that its governments and businesses make in order to address this phenomenon. Look at how its population distribution changed from a classic pyramidic form in the 1950s to its inverted form today. Currently, 30% of the population is over 65. Japan's current fertility rate is as low as 1.37. This is one of the lowest in the world. If the current low fertility rate continues, 40% of Japan's population could be over 65 before the population pyramid stabilizes. This is currently projected to happen around 2075. Population aging will be a formidable, though not insurmountable force to contend with in the coming decades. Japan has programs to increase the health of its society so that people can work as long as possible. It is raising the age of retirement and pension eligibility. It is increasing the size of its workforce by incentivizing female labor force participation. It has been recruiting caregivers from its Asian neighbors in order to help with its elderly care. It has brought into practice the use of robots and many other technical innovations in order to help caregivers of the elderly. Probably one of the most important evolutions of modern times that could not have been predicted is the numbers of people who are living to 100 years old. Here again, Japan tops the charts, with 74 people living to over 100 per 100,000 head of population, and their numbers are even increasing now. There are currently approximately 91,000 people over 100 years old living in Japan today. The percentage of women living to more than 100 years old predominate within the distribution. Professor Yasumichi Arai of the Center for Supercentenarian Medical Research at Tokyo, who studies the growing supercentenarian phenomenon, marvels at the incredible fitness and mental agility of some of his elderly patients approaching 100 years old. The coming of the age of supercentenarians is a feature of the future, and the ramifications for future nations with increasing numbers of people living over 100 years old is not yet fully understood. The interrelationship between climate change and overpopulation is a vast topic, and we are in danger of oversimplifying this ruthlessly unforgiving subject. We are currently trashing our beautiful planet with our pollution, fossil fuels, and abrasive lifestyles. There is only one planet which can support human life, and we should be looking after it a lot better than we currently do. Climate change is accelerating. The Earth may pass the myriad of climate tipping points with little chance of return to equilibrium. Any further delay in addressing these problems of climate change will worsen the effect. The climate weather that we are witnessing now may only be the start. In this documentary, we have only briefly touched on some of the causative effects of climate change. There are many other real threats which we will need to address in order to see the whole picture. For instance, as we see further melting of the ice caps, we're likely to further accelerate the defrosting of the deep permafrost, which could release an estimated 150 billion tons of locked-up carbon into the atmosphere. This amount of carbon is equivalent to 3 times what is currently globally locked up in our forests. The release of this amount of carbon into the atmosphere would have a devastating effect on the climate. Also, there is strong evidence that some of the deep-sea currents which circulate the Earth's oceans, which provide nutrients for plankton, which fish feed on further up the food chain, are weakening, and some of these currents could even eventually stop. This will lead to dire consequences, not only to the climate, but for the primary productivity and marine food chains that feed off the nutrients carried by these currents. However, there is one brutally truthful fact that comes through in this documentary. There are just too many of us living on this planet. Humanity in this world needs to stop avoiding honest debate on this topic of population and deal with this challenge in an impartial manner. This documentary has also addressed the science of sustainability and demonstrated the practical scientific tools that can be used to measure sustainability and Human Development Index. We need also to apply the technologies that we have, not only to reduce our emissions of carbon, but to also ensure that future generations have the knowledge and the ability to reproduce responsibly. Every child born into this world needs to be a wanted child. This will require a good education for all, equal opportunities, and a titanic change in attitudes. There are many icons of social changes that this earth requires, but one that sticks out above all others, and that is the world's gender inequality. Where women in society receive a complete education, the vote, free will, equal opportunities, gender protection, ready access to family planning, and the capacity to find good work, this will result in reduced fertility rates and eventually stabilizing populations. People will also be living longer in future, so it is expected that we will need to work longer in order to provide for our pensions in old age. If we understand all these facts and act upon them, then there is no reason why we can't expect a brighter future than the one that we have portrayed in this film. But if we don't,